Dear students, Assalamu alaikum. I hope you are fine. Today we are having a class on the second chapter of secondary physics, that is chapter motion. In this chapter, today we will discuss about falling body. Let us have a look of this picture. In this picture we see there is an apple tree, and under the apple tree scientist Newton is sitting. One apple fall on the head of Newton and he is feeling pain. It shows. That means what does it mean? That means the apple is coming down. What is this? That is, what is a falling body? A falling body is that when the body is let fall freely due to gravity, then it is known as a falling body. What you see in this picture, can you imagine? Can you recognize it? This is the Leaning Tower of Pisa. That is, in the city Pisa, there is a Leaning Tower. It is a tower and it is a bit inclined. And scientist Galileo carried out an experiment, which is known as Galileo's experiment. And in this building, Galileo carried out his experiment. Let us see what was it. This is the earlier view of the Leaning Tower of Pisa, and it is assumed that this is Galileo's hand, and here this is a falling object. That is, object is left here and the object is coming down freely. It is assumed. After this experiment, Galileo proposed 3 laws. What are the laws? Galileo proposed 3 laws of falling bodies. First law: all bodies falling from rest and from the same height without any resistance traverse equal distance in equal time. What does it mean? If we leave 2 bodies of different mass from the same height, then what we see? The 2 bodies come to the ground at the same time. That is the concept of first law. Second law: the velocity v acquired by a freely falling body from rest in a given time t is directly proportional to time. That is, v is proportional to t. What does it mean? The velocity of a freely falling body, increases with time. How it increases? If the time is made double, the velocity will be double. If the time is made 3 times, the velocity will be 3 times, and so on. Third law says the distance h traversed by a freely falling body from rest in a given time is proportional to the square of the time. That is, h is proportional to t square. What does it mean? That means height of a freely falling body increases with time, but in the form that if the time is made double, then the height will be 4 times. If the time is made 3 times, then the height will be 9 times, and so on. The time is made 4 times, the height will be 16 times. Let us have a look, let us enjoy a video clip on the first law of Galileo. So, have a look of the video clip.
This is NASA's space power facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems, and that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built outer concrete skin, which is part radiation shielding and part an external pressure vessel, so this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light bulb and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So, in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
We dropped 2 millitor in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 angle, 10% over. Station 1, go for drop. PCB 30-1, pressure set point 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Count 1, 2, 1. Release.
They came down exactly the same. Wow. Exactly the accurate size. Exactly the same. Photos were nothing. Right. That's just brilliant.
So students, we have enjoyed this video clip. I want to explain the video clip a bit. Here in this video clip, we found 2 persons. Earlier, this bowling ball and the feather are left at the same time, but in the vacuum chamber, there was air, that is air resistance. Due to air resistance, the bowling ball, that is heavy object, come earlier, and due to this air resistance, the light object feather came later. And in the second half, the vacuum chamber is made vacuum, and both the objects, that the bowling ball, the heavy object, and the lighter object, the feather, are left at the same time from the same height, and we observe that interestingly, both the bodies come to the ground at the same time. This proved Galileo's first law. This proved Galileo's first law, and here I want to mention something. You may enjoy this sort of video clips and which will help you to understand your topic. And if you go through the YouTube and search there. You can find these related video clips which will help you to understand the topic. Let us recall the three equations of motion when the body moves with uniform acceleration. The first equation, v is equal to u plus at. Second equation, s is equal to ut plus half at square. And the third equation, that is v square is equal to u square plus 2as. Here the explanation of the quantities. Here u is equal to initial velocity, v final velocity, a uniform acceleration, t time, and s is the distance. Why we recall these equations? Because from these equations we can deduce the equations of falling bodies. Here equations of motions when a body comes down with acceleration due to gravity, that is g. If we look carefully, then we see v is equal to u plus gt. Earlier it was v is equal to u plus at. That is acceleration a is replaced by acceleration due to gravity. That is v is equal to u plus gt. And the second one, it was s is equal to ut plus half at square. But here s is replaced by h. Then h is equal to ut plus half gt square. And then v square is equal to u square plus 2gas. In the equations of motion, it was v square is equal to u square plus 2as. Here the expression of the quantities: u initial velocity, v final velocity, g acceleration due to gravity, t time, and h is the height. Very important, equations of motion when a body comes down with acceleration due to gravity g from rest when it is dropped. That means when the body is dropped, we should know that the initial velocity of the body is 0. So placing 0 equal to the v of u, that is here u will be u is equal to initial velocity is equal to 0. We can get v is equal to gt because we know v is equal to u plus gt. Since u 0, so we get v is equal to gt. Then h is equal to half gt square, and then v square is equal to 2gas. All u are eliminated here. So we have got three equations. Basically, these equations are known as Galileo's equations, and the body which follows these equations is known as Galilean body, which is known as Galilean body. Equations of motion when a body is thrown vertically upward. In this case, acceleration due to gravity g is negative. Why g is negative? Because you are throwing a body vertically upward. That means the direction of velocity is upward. But we know acceleration due to gravity always acts downward. Here the velocity is upward and acceleration due to gravity downward. That's why both of them are opposite to each other. Here we consider v positive, since that's why g will be negative. So v is equal to u minus gt, and then h is equal to ut minus half gt square, and v square is equal to u square minus 2gas. All the same quantities earlier, that is u is equal to initial velocity, v final velocity, here u and v positive, g acceleration due to gravity which is negative, and t time always positive, and h height. Here height is also considered as positive. So we have got three equations of motion when a body is thrown vertically upward. Let us go for solving a mathematical problem. The problem is that a body is released from a height of 200 meter. I repeat, a body is released from a height of 200 meter. How much time will it take to reach the ground? One person. I repeat, how much time will it take to reach the ground? And the second person, with what velocity it will hit the ground? I repeat, with what velocity it will hit the ground. Before solving mathematical problem, I want to emphasize a point. What I observed that you do not go through the problem. I tell you to go through the problem first very carefully. When you go through the problem very carefully and when you understand the problem, that is how math is done. How problem is done. So this is very important. You have to go through the problem very carefully and repeatedly. So here two questions, that is how much time will it take, that is time is asked here, and with what velocity will hit the ground, that is with here the final velocity is asked to determine. The solution is given. Let us have a look towards the solution, that is here given initial time, here given initial velocity u is equal to 0. Acceleration due to gravity g is equal to 9.8 meter per second square, because this is the standard value of g. Height h is equal to 200 meter. Time t is equal to what? Because we have to find the time. And the second portion, final velocity v is equal to what? Because it is asked here with what velocity it will hit the ground. That means final velocity. Final velocity we have to determine. So we know h is equal to ut plus half gt square. Why did we choose this equation? Come here. We know u is equal to 0. It is known, and then acceleration due to gravity 9.8. It is also known, and h is equal to 200 meter. It is also known, but time is not known. Time we have to find time. So the three known quantities here in this equation, there are four quantities, three known quantities and one unknown quantities. All four quantities are here, three known and one unknown. So putting the values of three known quantities, we can determine the value of the unknown quantity. That is h is equal to ut plus half gt square, which is our required equation. We put the value, that is u is equal to 0 plus half gt square, or h is equal to, since it is 0, therefore h is equal to half gt square, or having cross multiplication we write t square is equal to 2h by g, or t is equal to, having the square root on both sides, root over 2h by g is equal to, now we put the value of the quantities, that is root over 2 into the value of h is 200 and the value of g is 9.8, and having the calculation we get the value of required time to hit the ground, that is 6.39 seconds. And we are going for the second portion, that here we have to find the final velocity. V is equal to u plus gt. We know u is equal to 0, and then g is equal to 9.8 meter per second square, and t is equal to, that is required time, 6.39 seconds, which we found in the earlier portion. Will be found in the earlier portion, or v is equal to 62.62 meter per second. That means the body will hit the ground with the velocity 62.62 meter per second. Now I will give you a homework. The homework here, the boy threw a ball vertically upward with a velocity 29.4 meter per second. I repeat, a boy threw a ball vertically upward with a velocity 29.4 meter per second. At the same time, another boy moves to catch the ball from a distance 10 meter with uniform velocity 3 meter per second. What happens? One boy threw a ball, another boy wants to catch the ball, and the second boy moves towards the ball from a distance 10 meter with a velocity 3 meter per second. So here are the questions. This is a creative pattern question. First, knowledge based question. What is falling body? You can answer the question from your knowledge. And number B, do all bodies take equal time to reach the ground falling from same height? Explain. This is a realization question, and you can answer the question from your conception. Number 3, determine the maximum height reached by the ball. This is an application. Okay. And number D, can the moving boy catch the ball? Analyze mathematically. It is a question of higher ability. It is a question of higher ability. So you will do this at your home and assess yourself whether you can solve it. We are going to the almost end of our lessons. What we learned from today's discussion. Number 1, what is a falling body? Number 2, laws of falling bodies. Number 3, equations of motion of falling bodies. Number 4, solving mathematical problem. Number 5, self-assessment or homework. We were passing through, my dear students. I want to give you an advice, that is, we are passing through a pandemic situation and we are passing through a very big crisis. So to save ourselves from the crisis, to protect ourselves from the crisis, what we need to do? We need to stay at home. That's why we are having this digital class. So you stay at home and stay safe. Inshallah, in the next class we will meet very soon. Assalamu alaikum wa rahmatullahi wa barakatuh.